Hi everyone, how are you? I hope you're doing well. It's nice to see you again. Right back to it. I'm sure you've all been very busy since our last meeting. Obviously, I'm not going to see you next week, and this week we have a quick online lecture from me. Monday afternoon. Sounds good. I'm going to try and keep things fairly brief. I know that the attendance is pretty low today, obviously with iteration 2 around the corner and the course having a different time for the lecture. There's naturally going to be a lot of people who don't turn up. But let's get into it because we're going to be talking about two things today that are fairly important. First one is code coverage. Code coverage is a really fun topic. It forms kind of one of the last pieces of learning that we do in the space of correctness. So if you think back to like weeks ago, we did our whole dynamic verification lecture where we thought about, what it meant to test software. And now we're kind of getting to the tail end of all that kind of thinking, at least for this course, hopefully not on your overall journey. And just like a lot of what we talk about from this point onwards, this will have pretty much nothing to do with iteration 2. It all has to do with iteration 3. So let's kind of get into it. Firstly, we need a mechanism to tell us how much our tests actually test. And it's a really interesting idea because if you've thought about it before, no doubt you would have kind of realized or remembered sorry about that. You can write code that passes your tests, but that doesn't necessarily mean that the tests you've written are good. And I think this is a really kind of trippy idea for a lot of people because it can be quite new, because you think, oh, if I've written the test, there's this idea you get in your head where writing the tests are good and your code, we'll kind of see how that goes against the test, right? So let me just quickly fix up the stream. Stream quality seems to be a struggle today. Yeah, I'm just going to reduce the quality slightly so that it doesn't kind of bump up and down. Yeah, excellent. So that should be good now. So we're gonna learn about how to make sure our tests are good by talking about coverage, right? Like various forms of coverage today. Now, firstly, what the hell is coverage? Coverage is a measure of how thorough our tests are. That makes a lot of sense, doesn't it? No real surprises there. However, there's two types of coverage we want to talk about. The first one is test coverage, and the second one is code coverage. Now, the easiest way I like to think about these is that test coverage is basically qualitative coverage, and code coverage is essentially quantitative coverage. So with test coverage, we're measuring how much of the feature set is covered with the test, and it's often left to human judgment. As I said, it's quite qualitative. So you might sit down and have a look at, say, a whole bunch of tests in front of you, and you might be like, well, we got to test auth register, we got to test auth login, we got to test this, we got to test that. And then you're like, yep, check. That's kind of what you do now in a way, right? Like as a group, you have probably applied the idea of test coverage to your work so far, and done so pretty intuitively, no doubt as well. Code coverage, though, is where things get really different. And that's kind of what we are talking about today and what you probably haven't really done much of, which is how do we measure how much of our code is executed during testing? Now, if you write, say, 10 tests, and then you have 100 lines, 100, maybe 1,000 lines of implementation, you obviously, if you think about it, want your tests to go and test every single line of the code you've written, right? Because if you've written code that isn't tested, then you've got code you've written that no one's kept an eye on. And again, that might make sense, but what we really care about is the fact that we're trying to do it numerically. The fact that we're trying to say, how can we compute this and quantify this exactly? So when we talk about code coverage, there's lots of different ways we can understand it, but one of the simplest ways we can do it is to say, you have 1,000 lines of code in your implementation. We are going to measure your code coverage as a percentage of the total of those 1,000 lines that you execute whilst the tests are running. So if you, for instance, have only, 200 of your 1,000 lines of code that are ever tested, then your code coverage would be 20%. And it's a really great way to give us a good indication of how much of our code's being executed, and most importantly, highlight what isn't being executed, because that's kind of the key of it, right? Like the reason you would run code coverage tools on your code to understand the coverage of your code is quite literally just to be like, what aren't I testing so I can go and test it. That's really the outcome that we're kind of wanting to achieve here. So what do we do if we want to test code coverage? We need ways to do it. And we've got 2 pieces of sample code today, and we're going to write some tests, and we're going to use the coverage flag in our package.json that you'll see. We're going to pull up the code, and I'm going to take a look at it for you. So let's take a look at this. Week 7.1. Firstly, let's have a look at the package.json. You'll see that there's nothing actually particularly new here in terms of, the way we do testing with, let me just double check I haven't missed anything. Yep. The way we do testing with coverage in JavaScript typically is just with Jest. So Jest is this great tool, and it has coverage checking kind of built into it. And that's really, really cool because we don't need to kind of go and install a separate library. So there's some languages out there where you will need to go and install a separate library, but not necessarily JavaScript. So I've got a really simple file here called isLeapYear. What I'm going to do is I'm going to try and create, give me a sec, I'll just create another file. isLeapYear.test.ts. Cool, so I've got myself here another file called isLeapYear.test.ts, and I've got my isLeapYear function. It's a fairly straightforward function. It does the kind of usual check where we're like, okay, what year is it? We check if it's divisible by 4, then 100, then 400 to see if it's a leap year or not. And what I'm going to do is I'm simply going to import isLeapYear from isLeapYear. Yep, that makes sense. And then after I've imported isLeapYear, what would I like to do? Well, I would really like to write a test. So describe testing is leap year. And then I'll do, say, test. What are we going to test? Test even, or like, years divisible by 4, say. Something like that. Or like, odd years maybe is a good starting point. Odd years. So now we say, I expect that calling is leap year on 2023 to be false, because it's not a leap year. Okay, and then we have something really simple. So normally what I would do is I'll go into my 7.1 folder, I'll go and npm install and do the usual stuff here, because it's kind of a new project and whatnot. Just kind of sit around, wait for it for a sec. Got to pass the time somehow, don't we? Just going to turn down the exposure on this camera slightly. It's a little bit blown out. Cool. So we've got that thing. Now I can run npm run. Let's have a look at our package.json. Jest. Let's see what this does. There should be one test file in the project. Okay, so we passed our test file. However, the normal Jest running command doesn't check any coverage. If we want to check coverage on our code, what we need to do is we need to add the -- coverage flag to Jest itself. So now when I run it, you'll see the output here will be slightly different. I get a different kind of output. And this output's pretty interesting here, as you can see. It tells me a few things. It says, hey, your isLeapYear function here, you looked at 37.5% of statements. So if I go back to my code, my data year, because remember, coverage is leap year, sorry. Coverage is a tool that looks at your implementation and counts the number of lines that your test ran over it. So in this case, I've got an 11-12 line file here, and it's saying that when the test ran it, the test covered approximately 37%, about a third of all the lines. Now that's really interesting. That's not a lot of lines. There's obviously still some problems here, and that's okay. That's why we're here. Yeah, we just want to fix it up and get those lines, the other 62% of lines that aren't covered. Now, here's the thing. This little summary on the terminal is kind of useful. It tells you a few pieces of information. Here it says uncovered lines, which literally says that you did not cover lines 4 to 9. Now that makes sense because I passed in 2023, and when you divide 2023 by 0, it has a non-zero remainder, and therefore this function returned false early, and I never covered these lines. However, if I type ls, right, you'll also see that there's a folder that exists that didn't exist before, and that's the coverage folder. And if we go and have a look inside the coverage folder, there's a few different things that are there. Namely, we have this XML file and a JSON file, and then we have another folder called lcov report, and then inside of that, you'll see that this is basically a website. That's what we're looking at here. Now, what I'm going to do just over in my file explorer on the side here is I'm going to go into coverage, lcov report, and then I'm simply going to open up that index.html file here. I'm just going to drag that straight into the web browser here. Now, this is cool because what this is this is just that is basically making a web page for you that gives you the detail. Now, what you see at a glance here is identical to what was on the terminal, right? But if I click on that, it actually gives you a really cool visual breakdown of what lines aren't covered. And this can be really helpful because you imagine throughout your iterations, you might have written some tests for your code and you might be passing, like most of you pass 100% of your own tests, but then when there's external tests, you fail. So it's like, where's the difference? Great idea. You can apply code coverage to it. So what I might do there is be like, okay, well, I can clearly see that, well, I'm probably not testing cases where, maybe just like, what would you say, like non-100, non-400 year leap years, right? So let's test a few more of these. And the non-100, non-400 leap years might be kind of literally just like this year, 2024. So I say, yep, okay, I'm going to update my tests. And then I'll come back to the terminal. I kind of have to go back to the original folder like this. And then I have to run my npm run jest again. And this is the cool thing. It'll give me a new output, but I can just go back to my web page and I can hit refresh. And now you see I've tested more. So now we've got a case where the year divisible by 100 is not equal to 0. Okay, that makes sense. So because this first if we didn't get into it, it means that it is divisible by 4. And then because it's not divisible by 100, it's therefore a leap year. And that kind of very naturally leads us on to think, well, okay, well, what else is there? We say leap year divisible by 100 because every leap year, but not 400. Every leap year that's divisible by 100 but not 400 is not a leap year. So when we get to the year 2100, some of us might be alive then. That is actually not a leap year. And that's what our code should do. So we run that again. Now we're at 85% coverage. That's good. And then the final one is our classic leap year is divisible by 400. Because if the year is divisible by 100, it is not a leap year unless it is divisible by 100. So try that one out. Oh, what do we do wrong now? Sorry, that should be true. Easy, 100% coverage, perfect. So if you pay attention here, we went from covering, 37% to 62% to 87% to 100% of all the statements. And that's a really cool thing. We've written better tests that way. Now, this might be tempting to kind of say, well, why don't I just write my implementation and then start writing tests and try and get all the coverage? It's still generally important that we try and write tests first, because again, what that will do is make sure you don't accidentally bias your implementation, right? And that can be really important because it's really easy to bias implementations. However, whilst you want to write tests without a biased implementation, that doesn't mean that your test will be perfect. So then what we do So then what we can do is that so you've written all your tests and you write all your implementation, but you know your implementation is not going to be perfect. So maybe you run coverage. Now, if you've just been writing tests as you go, and this is true for your project and stuff, you should probably expect a coverage of like 90% straight up. Like you've written tests, it should be well covered. However, you're going to miss some stuff, and that's pretty normal. So to solve the missing stuff problem, the next thing that we would do is run coverage and be like, we missed some tests and we go add stuff in. Because no one's going to write perfect tests the first time, That's like just an absurd thought. So to manage that, we use coverage tools like this. You can apply this to kind of any bunches of files. We've obviously got our leap years one here. There's also another file we have called day to year, where we essentially convert a day to a number of days since 1970. So I could do a very similar thing here, right? I'll go and create myself a day2year.test.ts file. That's what I got here. And I'm going to go and copy my is leap year test file. Let's see, what do we got? We got to export this one. Export. I'll just rewrite this slightly differently. Export const data year equals that. So now we're exporting this function that I wrote. We're going to go import it here from day to year. And then we'll say, let's test out some days in 1970. So we know that day to year, oops. We know that day to year, if I pass in 0, should give me 1970 the year, because 0 days since the start of 1970 should be 1970, basically, right? So I can go and kind of run that one as well. And now in this case, I know I'm writing tests from scratch. That's just more to get the point across. But if I was to say run npm run jest now, let's pay attention to what happens. And what happens is really interesting. Besides an error, let me fix up the error. What have I done wrong? Day to year. Oh, yeah, okay. I really did just write that poorly. Perfect. So run this properly. Here's what you'll notice. Now there's actually 2 outputs with jest. So you know when you run jest and it kind of runs stuff on all the files, if you run jest with coverage, it will also go and just run testing and coverage on all the files. And that's what we're having here, where you can see the is leap year file is 100%. The data year file, though, is only 50. That's not good because we've missed a bunch of lines. And overall, we've done 70% of the statements. So now I can go back to my little code coverage thing. I can click on all files. Now you can see I've got data year here. And you can see here, well, it's simply not quite getting to other days. So then you think, well, okay, well, let's test a few other things. I'm going to test like a 1971 day, which I know might be like 380 days in the future, right? At least 1 year. Cool. That sounds good. I go and run my coverage again. Runs. Great. So now you can see what's happened is that because I entered, because the year we were in at the time was not a leap year, because I think 1972, I guess, would be a leap year. It never returns true for this. So the is leap year function is called because every time you loop through a day, you're checking if the year you're in is a leap year, of course. However, you think, well, I actually need to get to 1972. So for that, I'll need to do about 720 days, something like that. This would be a bad way to write tests, but I run it again. Now I should be able to enter that loop now because at some point while this code is running, the year is going to go from 1970 to 71 to 72. Oh, I guess it didn't. We should have entered that loop because I'm surprised we didn't enter that loop actually. Oh yeah, we did enter. Sorry, we probably entered the loop before, I guess. Is 1970 the leap year? No, it should be 1972. Yeah, I mean, I guess that makes sense, right? Because like once you call this line, if you enter it and do nothing, it's the same as, let's get rid of this. Let's just make sure I didn't kind of miss a subtlety here. Should be the same, right? Yeah. So it's not enough to do that. We need to get to a point where the number of days, like where we actually reach the 366th day. Yeah, so days looks like it's, yeah, so if it's greater than 366, days minus equals. So this is kind of where it's useful to step through the code. So it starts off being like, well, days is greater than 365, which it is because by default it's 760. Okay. If is a leap year, it's not. It's 1970 currently when the code starts. So we go down here, days minus equals 365. Sure, so we basically click it into 1971. And the number of days in this case goes from, 760 down to 400. Cool. So then we come back into the loop. Is days greater than 365? Yes. 400. Is it a leap year? 1971? No. So we don't enter that. Then we come down here and we take it off. And it's like, oh, okay. Well, this makes sense. What's actually happened here is that even though we got clicked into 1972, because how we tracked through the code actually never needed to run that point. So it's a little bit of a funny thought, but it's like, well, I know it's 1,000 days to get me into 1973, roughly. So now if I run this again, we should get into it. Now, the cool thing, or is it 1972? I guess it would be just, wouldn't it? Still 1100 days. Cool. So the interesting thing about code coverage in these tools is it actually lets you really think about how the code works. Because in this case, I might have intuitively said, oh, well, I'm testing a number of days that gets me into 1972, so it must test it properly. But the way it actually worked was it was only kind of like, you know, the is leap year function here only really happened once you kind of left 1972, so to speak, and kind of got into 1973. So it's like, this is great to test this way. It's really good. I guarantee you, and you'll learn this in iteration 3, because you don't really need to do coverage for iteration 2. You're not marked on it directly, but it's like, once you get into iteration 3 and you start running coverage, you'll be like, oh, I see there's a few things we messed up. And it'll be really insightful and make you think about the areas of the code that you could have done better, basically. So coverage command summary, we run jest coverage to run tests with coverage on. We recommend that you put this in your package.json script. You don't need to either though. For instance, if you don't want to put it there, you can actually run it very differently. You can just run npm run jest on the command line. But if you haven't kind of figured this, well, if no one's showed you this, you can actually add more flags if you want to the command line. You can't really just add -- coverage like this. The npm thing ignores it. You have to add a -- before you -- It's a bit weird. But that will actually run the coverage. So you don't need to add it to package.json, though it's generally recommended. And you can access the HTML summary in coverage lcov report index.html like I showed you. Now, one thing we did kind of gloss over here, though, is branch coverage checking. This is a really interesting topic because what you see in the little table over here are different types of things to check the coverage of. And you can see this one is statements and this one is branch. So a statement check, and functions too, but a statement check is basically something where it'll check kind of like every line of code, right? And it measures it based on there's a total number of lines of code. How much of that did we get good coverage on? Branches, though, is an interesting one. It essentially looks at every single time that you could have an if or an else statement and go into a different possibility, and it counts that as a branch. So if we look at, say, our original piece of code, let me get rid of some tests here, right? So I'll get rid of a bunch of these tests. Okay, so what's my coverage now? It actually says 0, is it 0% of branches? Yeah, 0% of branches. That's really interesting because if I look at my code, and you can also see it here, it's like how this function works is that we start off here and then we have one branch. Basically, like we get to a junction point where we can either go down or into the while loop. And then inside of that, we can either go down or into the if. You know, into the if or the else. And then the next one, we can go into the if or not into the if. So it's kind of how it looks at it, is it really centers it around 4 while loops, if else statements. And you'll kind of see that if I just do something simple, like say add this one test in here, you know, we go from 0% branch coverage suddenly to 33% branch coverage. And why did that happen? Well, because I entered the while loop now, and it looks like I always went to the else statement. So they're basically saying, well, I can see that there's 3 branches, this while loop, the if else, and then the if inside of that. And I can see that you did go into the while. At that branch point, you went both ways across your tests. But then in the next if statement here, you didn't go both ways, you always went to the else. Okay, so you know, you kind of keep layering it on like that. Now, you can see branch coverage is only 33%, whereas statement coverage is 75%. And that's really interesting to think about because which one is kind of a better measure? You know, that's essentially the question. And there is no real great answer to that. But what I would say is that a lot of people would consider branch coverage to be pretty useful because if you look at typical pieces of code, whether there is 1 line here or 2 lines here or 3 lines here, the reason your tests fail is typically not because, you know, it covered 1 line but not the adjacent line. The typical way it'll fail is because you didn't explore an entire, you know, path or an entire, you know, divergence in your code. So branch coverage is really, really useful. We don't use it in 1531. We had some issues with it under some specific circumstances. We'd love to though, because it's pretty good. So we do use statement coverage when we do your marking, or line coverage. I can't remember off the top of my head, but they're pretty similar as an idea. You might be like, what's the difference between statements and lines? Well, as a general rule, a statement is, I won't really go into it here, but if you look at programming languages, there's ideas like expressions and statements, and a statement's made up of expressions and a line's made up of statements. Statement versus line programming. Maybe it'll here, like this will just get you thinking about what's the difference between a statement and an expression. So, so const price equals and 500 in this case are, where'd it go? Yep, so like let and amount and 2000 are expressions. So 2000 is an expression, but the whole thing forms a statement. So expressions are like little pieces, statements make up. I like to think of them as lines of code. I don't know if this is the best example in JavaScript. Maybe it'll be the quickest and dirtiest one, but because like if we look right now, we have 75% statement coverage and 72% line coverage. If I go and put these things on the same line, let's see how it differs. Yeah, so you see my statement coverage stayed the same, but my line coverage went up. So that's kind of why line coverage isn't too useful, because it literally just tells you the lines, and lines don't really mean anything strictly. Whereas statement coverage kind of refers to the statements. But as programmers, we typically go and put, one statement on a line as a general rule, so it's not really like a problem necessarily at all. So yeah, branch coverage is really interesting. Sometimes it's referred to as edge coverage, but it's a great little thing if you kind of get out of the course and you go look at some other stuff. So in summary, code coverage is really useful. It's more important to look at what's not covered than the coverage percentage. So it's a tool that helps you unmask problems with the code, and that's really exciting. Branch coverage is more accurate, so you should generally use it instead of statement coverage. However, in the course, we still do your automatic assessment in iteration 3 with statement coverage. And like all measurements, it's important to understand the meaning attached to it. This is kind of where that debate around branch coverage, statement coverage gets really interesting, because there might be some instances where statement coverage is actually more meaningful or less meaningful depending on your application. So context is really, really important there as well. Cool. Now, are there any questions about that from anyone here in the chat today? It's a pretty straightforward lecture. Generally, things are pretty light. Because it's week 7, it's kind of how the course is designed to not be, too onerous on you, essentially. Waiting around for some questions. See if anyone has any. Can we use this to optimize code? I wouldn't say that code coverage helps you well, I can see what you're saying. Like, can we optimize code by like looking at what we're not using? Maybe. Like, yes, you could identify this is a part of the code that the tests don't cover and therefore we don't use it. But you'd have to have such certainty that your tests are indicative of all real world scenarios. Because quite often it's very difficult to get tests exactly identical to like how you're going to use it in reality, But yeah, that's potentially something you could look at. It's not an outright impossible idea, but it's probably not super common. That's for sure. Cool. Well, hope that was useful. Hope you enjoyed a little bit about code coverage. Thank you. We're going to take a break. We're going to come back to the second half of this lecture today. Again, it's all pretty light today. So take a 5-ish minute break, and then we will get moving into deployment. Cool. Hi everyone, welcome back. Hope you're having a good time. Just before we get started, someone has asked, quick question, because we have wrapped our test for HTTP, coverage seems to only check the test helper.ts file and not our implementation files. Is there a way around this? So, just as I understand it from at an abstract level, here's what's here's what's going on. When you run coverage, what it does is it basically finds the .test files, and then it looks at all the code that isn't in that those .test files that the .test files execute. You know what I mean? So it's like you have the .test files, they go and try and import all this other code. All the other code that isn't .test.ts will be part of the coverage check. However, it doesn't really work with the server, because with the server, you're not really importing files. You're making an HTTP request to a whole separate thing. However, for your like labs in week 8 and iteration 3, which is released, I think, next week, there's stuff that's provided in the files to you to solve that problem. So all I'm saying is, if you're trying to manually use coverage right now without that stuff, you'll run into problems. So either you'll have to wait till there's like one of the later labs where you can go steal some code from that, or iteration 3, there's a way around that. The course has kind of invested the time into making it work. It's a little bit fiddly, right? Because you basically need to spool up terminal A, which is running the server, and then terminal B runs the tests. And as terminal B is running HTTP tests, you kind of need to watch what's going on in terminal A and run coverage that way. We figured it out. It's not the hardest thing in the world. I'm sure like ChatGPT could tell you too. But yeah, it's not something that you would just add -- coverage to a server stuff and it would work. So kind of sit tight for that one, I'd say. Deployment. This is one of my favorite topics. I love talking about this. It's a pet project of mine. I was kind of introduced into the course by me. It's one of the few things that was really keen on introducing into the course years ago. I won't kind of spoil the fun, I guess, but let's just start talking about it, because who the hell knows what deployment is? It's a bit of a broad term. This is why we're talking about it, though. The purpose of the vast majority of software, most is a bit of an understatement, I think, is for people to use it, right? Like that's kind of the classic, what are engineers? Engineers are people who take science and apply it to the world to improve the lives of people. Engineering is all about people at the end of the day. I used to do these talks for the uni, and I used to say, it's like, if the population of the planet suddenly went down 90% tomorrow, like big disaster, the amount of engineering we'd probably have to do would also be about 90% less. It's not that simple, because engineering doesn't just work on a per capita basis, but it's like we as engineers, we build stuff for people to make their lives better. And the more people, the more problems, the more engineers have to do. Therefore, when we're making software, we're mostly making software for people to use it, directly or indirectly, right? Even if we're building systems behind the scenes, like if you're building a buffer optimizer for Netflix, that's still software for people to use. You're trying to improve their experience. And for the software we write, to make that available for people to use it, we need to, engage in processes to make that available, right? It doesn't just happen instantly just because it can. So that's really what we're talking about, is how do we make software available to people? So deployment, availability of software systems, pretty simple idea. What I love to do in this lecture, it's kind of one of my favorite things, is I love to explain deployment in a really, really, really basic way. And that is using the CSE account. Now, on the CSE account, if I just SSH into my account, right, or I'll just use my Z number, so it's kind of clearer, right, .csc.unsw.edu.au. Give it a sec. Yep. So when I'm in there, I can go inside a folder that every computer science student in CSE has called public HTML. And I can make a file there called fruit.txt, right? In that fruit.txt file, I might put in banana. Like this. Really simple file. And then what I'm also going to do is I'm going to add permissions to the file, which you kind of have to do. It's a bit boring, but you got to do that. And now here's what's cool. Anything inside that public HTML folder, if I simply now navigate to cgi.csc.unsw.edu.au / my z number / fruit.txt, the file, there is now this banana. Didn't work. What happened to my banana? Sad. Yeah, so now there's this banana. You can look at this right now. If you're listening to this lecture live, recorded in a month, if it's November, you can load that up and you will see that anywhere on the planet. Anywhere on the planet. I have just made banana available for use to anyone on the planet. Now, what's really cool about that is I might not always be working on the CSE machine. You know, I might actually be working on my own machine. So here's a little terminal of my computer, right? Because the one on the left is the CSE machine over there. And what I might do is I might create a folder called Fruit Project. And I might go into Fruit Project and I might literally make a file called fruit.txt called apple with a little apple emoji. And here's what I do. This is my software, right? This little text file. Think of that like my code. Every time I kind of am happy with my code, maybe I git add it, git commit it, git push it, whatever, I can deploy my code to the internet through a very simple command, which is I say, I'm going to send a file over SSH fruit.txt to my CSE account in the public HTML folder. And what that will do, and you could write this command too, anyone could do this in CSE, that will take my file and it'll send it to that particular address on the CSE account, right? Now, here's the cool thing. When I then go back to my web browser and I refresh the page, it suddenly says Apple. And, you know, if I go and, you know, work on my thing, Apple and Mango, I'm like, okay, I've updated my code. I can simply then go and push it. I can deploy it up to the internet again if I'd like to. It'll take a moment because it's got to send it over the network and stuff. And voila, Apple and Mango. There it is. Really simple, right? Deployment is a pretty straightforward idea. It's taking software and making it available for use. Now, when we say make it available for use, typically we mean put it on the internet. You know, the software historically was sent out on CDs and stuff, but in this case, we kind of mean put it on the internet. So you can deploy, I don't want to say anything because you can't just put a C program up there and it kind of works. You know, there's certain limitations with the web, but as a basic rule, you can make little web pages available. So for instance, let's imagine that in my project, I'm also going to have a file called like, you know, fruit.html. That's a web page. And inside that, I'm just going to go and put the apple inside of some kind of header like this. And now I'll kind of do what I did before, except this time, instead of sending fruit, I'm going to fruit.txt, I'll send fruit.html. Now this might have issues because I haven't given it the permissions that I had to do before, but we'll see. Fruit.html doesn't exist yet because it hasn't been deployed for the first time. And sometimes the CSE accounts have a cache on them, which might slow it down. Let's check out the other terminal, see if it's there. Fruit.html. It is there. Let me give it permissions. The cache sometimes will just slow it down, but it should still. That's weird. TXT works. There we go. There it is. Now, it clearly doesn't like displaying the emojis for some reason. Let me just change that. Yeah, I'll change this to like, you know, apple and mango are my favorite. Now I'll go deploy that. I've updated my code. You know, I'm making a website. Cooly. There's my website, right? So I just made a website. I can be on a boat in the middle of the Pacific with an Elon Musk Starlink looking up this web page right now. Made it available anywhere on the planet. Completely useless, right? But that's the basic gist of deployment. The history of deployment is important to understand though. Historically, deployment was much less frequent and much more physical. if you think back to, say, the 90s or the early 2000s, it's like, well, even the mid to late 2000s, it's like, what did we do? Like, there were game developers out there. They worked on a game, a PlayStation game, an Xbox game. They finished the game. They put it on a CD. They sent it away. The same thing used to happen with operating systems. So deployment as an idea of making software available for use was very different. It was essentially about shipping something out, right? And it might only happen once a year or once ever, frankly. You know, like once they make a video game back in 2005, they would just make it, put it on the shelves. People would buy it. That would be the end of it, right? So something changed though, and two really, really important and big things changed. The first one was the increase of performance of web apps. Basically, more and more stuff could be done in the web browser. This was really powerful because it meant that whether you had a phone or a tablet or a laptop or a desktop or something like that, you were able to run software through the web browser over the internet, right? And then the second part, naturally, that was really important was the improvement in internet connectivity, speed, and bandwidth. So these changes basically allowed for the pushing of updated software to users to be substantially more frequent. E.g., think about how quickly Facebook is updated these days. Yeah, so whether it's Facebook, Instagram, doesn't really matter. These things are updated on the fly. So there's basically been a movement from software as a physical asset to software as a service, something you access and stream online, that has catalyzed this transition of what we mean by deployment. Because 20 years ago, there wasn't really much of a topic around making software available for use because you just kind of worked on it and then it was done. You know, and you'd work really, really hard to make it done, and then it was done and kind of handed over to someone else, right? Like putting something in the mail. Once you drop it off at Australia Post, it's like it's gone, out of your hands. You can't change it anymore. If you sent the wrong thing, you just sent the wrong thing. You know, you're kind of screwed. But now it's all over the internet, and that means we have to have really thoughtful, robust processes in how to make this stuff available. You can go read some stuff if you'd like to. One, I guess, important elephant in the room is that the act of making this stuff available essentially was powered largely by companies. And I apologize that this slide is quite out of date. I'm gonna edit it. It just annoys me too much. Let's change this one to Google Cloud Platform. Let's change this one to Azure. There we go. I feel better now. So this has all been powered by the fact that, you know, even though you can push something up to the CSE account, right? And someone can access it. But that's just CSE having a little service that they run. It's not a scalable thing. It doesn't really work for millions of customers. So all these things you use, like Instagram and Netflix and Disney Plus, they all use these cloud providers. And the biggest cloud providers are by, guess what? Google, Microsoft, and Amazon, typically. You know, there are smaller ones out there. There's tons of them. But these are what kind of power it. So when we say deploying our code, making it available, typically what this means for 95% of cases is that you have code on your computer or in a Git repo, and you need to share it with a cloud service like Amazon, Google, or Microsoft. And they kind of manage it in an abstract way. And then when the people you want to make that software available to would like to use your software, they go to some website or some equivalent, which talks to Amazon, Google, Microsoft, whoever, and gets your stuff, right? They help make it available. So they're the equivalent of CSE in that little cute thing I made here, right? Because this is all just on the CSE. I don't know if it might even still be in the building in CSE. I'm not exactly, can't remember if they moved it to AWS or not, but it doesn't really matter. It's in the cloud one way or the other. So now what we're going to do is really quickly recap continuous integration. So continuous integration was the process of automating the integration of many code changes from many people into a single software project, right? We kind of understood that as pipelines as a topic. The pipelines were there to make sure that lots of different pieces came together. What we're going to be talking about now is an extension of that, which gets us into this other part here, which isn't called CI, continuous integration. It's called CD, which is continuous delivery. Continuous delivery is what we do after we have continuously integrated all of our software together, you know, through the pipelines, right? Because you think about a pipeline and all these systems we have testing and linting, their job is to make sure that whatever ends up in master is perfect. So then the next question is, what happens after it's in master or perfect? We need to make it available. And that typically involves pushing it out somewhere, whether it's a CSE account or on the cloud or whatever you will, right? So this idea of continuous delivery, it allows us it allows accepted code changes to be deployed to customers quickly and sustainably. typically what you do is you build a whole bunch of automations, a whole bunch of, processes that you can, automate so you don't have to manually do it every time. Because you can kind of call this manual, right? Like I'm manually writing this up. A really simple example of automating it might be like I'll create a bash file called deploy. And all that bash file will do is push it up to the cloud, right? So like that. So now I've got this little deploy command. So this is kind of like you can imagine this as continuous delivery in the simplest sense. I've written myself a little thing where I have to hit the button and it goes and deploys it up for me. So, I go and edit my file. I maybe add a few other of these just for fun. And then I go, yeah, let's deploy it. Bam, there's my button. I'm going to hit deploy. And suddenly I'm refreshing my page. It's not deployed yet. It's not deployed yet. At some point it's going to be deployed and you're going to see a lot more pieces of text. There we go. Right? So this automation and then a manual release process is really key. Many companies will do this on a daily or weekly basis. Sometimes they refer to this as deploying it, releasing it, shipping it. There's lots of different pieces of terminology involved, but continuous delivery involves the process of someone typically still signing it off and being like, yep, this sounds good, let's release today. There are some companies that do this, right? So lots of engineers will work on code, and then every day or every week or every hour, doesn't really, like whatever the time frame is, someone will go, yeah, this is better, we should release it. And they click a button and it all goes out. It's a really rapid, automatic way to get code out pretty quick. It's also why like software's in a way more buggy than ever, because in this push because we can push updates to code so often, like I've met companies that have hundreds of thousands of Australian customers who are pushing code out every 2 hours. So every single time an engineer makes a change that passes all the pipelines, it's out in the hands of customers. That's great because it means everyone gets features and updates and security updates and all this wonderful stuff really quickly, but it also can kind of lead to bugs as well. The interesting thing is to talk about how we release it, right? So this continuous delivery is concerned often with more than just saying, well, we need to go from your computer, your development environment, or a GitLab repo to production out, live in the real world. There's scales of this. You can have not much in the way of steps, or you can have many steps. So for instance, here's an example of something that I see somewhat commonly. There will be, if you're working at an organization, every single time someone merges to master, they might go and have it automatically deployed to like a really fast-paced development environment, as in like, where it's got the latest code changes all the time. And then if people are happy with that, right, maybe after a couple of days, they'll go and push it to a test or a staging environment. This is basically something that emulates the real website, but it's not really true. So instead of netflix.com, it might be a website that you and I don't know about called testing.netflix.com. And that's where things like, internal employees or some customers who are really keen beans might actually go and really test the software to see if it's okay. And then once people are happy, they'll release it to prod, live, production. There's a whole bunch of different ways you could call it. So it's essentially this process of kind of moving it through stages. What you saw me do earlier was where there was no stages. It went straight from a local environment to production with the click of a button. And as a program becomes more complex, as it becomes more high risk, as it involves more people, as it affects more people, it is going to go through more stages. The example that I always like to use is this one, and it's only useful to me because I did an internship there a long time ago now. But it was really interesting to me because when I was at Microsoft briefly, it was at a time right when they were releasing Windows 10. And Windows 10 was interesting to them because kind of before Windows 10, I mean, they kind of been doing this a little bit, but Microsoft was really gearing up 10 minutes ago to kind of stop sending out CDs, basically, right? So it was like, well, really do little updates, but they kind of wanted to jump on the bandwagon of what Apple and Android had started to do. In particular, Apple at the time, where like, you get an iPhone, even like in 2010, it's just the iPhone. You get updates. Eventually they stop the updates, but they just keep sending big, deep updates, over the internet. So Microsoft were kind of looking at this, and I just remember this diagram because it was in the team I was working in. It was the team next to my team that was doing this stuff. And they kind of showed how there were kind of stages, essentially. So they were like, every single day, when people are working on Windows, the operating system, it gets built every night, compiled, right? And the engineers can look at that every single day. In fact, a lot of the engineers in the team would be having the daily build of Windows. So their operating system would be literally compiled the night before. And this was great because it was buggy all the time and they'd uncover all the bugs. And once they were like, yeah, this seems pretty good, we've like, this was a milestone. They like pushed it out to the next line, right? And that line was, people in the company that were really keen beans to test it out. Everyone who worked in the Windows division of the company. Then eventually they push it out to all the employees of Microsoft. And eventually they push it out to all the customers who are keen beans, super keen beans. And then there were, the less keen bean, but still keen bean customers. And the whole point of this was that by the time you hit an endpoint, the actual everyday customer, it's been through so many rounds of essentially getting it right. So this iterative process isn't just like you write code, it's done, you write code, it's done, right? Because we often think about iterating in that sense, but there's a way where we need to iterate our work out to a larger and larger group of people to make sure that we've done it right, because it's just a side effect. So much code is being written by so many people all the time that it's just so rarely done correctly. And it's a very different industry, like if you look at an industry like, say, aviation, right? I love aviation. They work on, you wouldn't even believe how long they spend working on planes, like, I'm trying to think about it. I think it's like the A380, it's a very recognizable plane, right? I don't know where I went to, I was trying to show you, right? It's the double-decker plane. It's the thing, Emirates, you'll see these come into Sydney and stuff. A lot of people know them. I think it was 2008, 2005, right? Was when they had their first flight, I guess. But like, when did the A380 start development? 1988. It was 17 years. There would have been people who joined the company after they started working on it, worked there for over a decade, and then left to join another job before the plane even flew. Different types of engineering, right? Because once those planes are made, there's only so much you can do with them. They have to work, and they kill people, if you get it wrong. Software is a funny industry because there's certain types of software, right? Like everyone's kind of seen those SpaceX landings recently. For those listening in the future, potentially they caught the rocket with the chopsticks or whatever it was. And, there's like car systems. There's lots of things with software that have to go right, But generally speaking, if you're writing software that people access in a web browser, or in some kind of computer terminal, it's low risk. And that's created this industry where people are just going to thrash through things, just make stuff all the time. Because if you can't, like Westpac was down for like 4 days last week, no one died. It was annoying as hell. Like I'm a Westpac customer on two fronts and, I couldn't get my money. I couldn't move my money. There are all these problems, but no one dies. And there's a certain, I guess, equilibrium that happens with any kind of institution where, the lower the impact, the more risk taking that exists. And then you get these applications like, maybe Canva is a great example, or Duolingo, where like literally the worst thing that happens is people can't do this pretty immaterial stuff anyway, So like, let's go fast because that's your advantage, is just being innovative. So you need to iterate quickly and move out quickly. So the way even these kinds of rings work will be very different depending on the type of software that you're deploying and how you're making it available for use. Now, there's another term you should get familiar with, which is continuous deployment. Continuous deployment is like continuous delivery, except the release decision is automated. So when we often talk about deployment, these days I think we are probably talking about continuous deployment more often than continuous delivery. What I would typically see happen these days is that if you have a piece of software and it passes all of your tests in the pipeline, that's usually enough for a system to say, it's probably good. Depends again on the company, the product, the risk, and all of that. But it is pretty common now that it just kind of rolls out automatically. The most common way I'll see it do it is typically overnight, sometimes intraday, sometimes weekly. It really depends. Like say at my company, right, we roll out, I think at 11 p.m. every night now, or 11:30 or something like that. And we do it once a day because we want it to happen at a time where the engineers are kind of maybe awake, but also the customers are not really going to be using the platform. But like even we have discussions internally about, should we say do a deployment at say 8 p.m. or 9 p.m. where if there are issues, we can kind of catch them and, because there's times sometimes where things will fail overnight and people will just have fallen asleep. do it at 9 p.m. and 7 a.m. So it's like, well, you get one out at 9 p.m. for all the work that was kind of done and locked in that day, or maybe even 6 p.m. Right? And then if there's issues, you catch them in the evening. And then for anyone who finishes work quite late, or something doesn't get approved till the morning, it gets pushed out in the morning, right? Like, I don't know. There's good and bad parts about that. There's no right answer. It depends on the circumstances quite extensively. But the point is, continuous deployment is when it's automated and there's no real decision point anymore. Okay. This one, I'm sorry. I think I used the wrong slide deck today. Let me just fix this up real quick. So this term, COMP1531 has decided to use a free service known as Vercel to let students deploy their back into the cloud. Instructions of how to set this up are found in the project repository for iteration 3. So we actually give you a great step-by-step guide on how to use this to deploy your project for this term. It is free. However, they will occasionally try and ask you to upgrade and enter a credit card. Please don't do that if that's the case. You should be able to do everything you need to in this course this term without ever giving anyone a credit card. Under no circumstances, don't give the company a credit card. There have been some students in the past that have done that when they maybe necessarily, shouldn't have, because we didn't ask them to, and it has caused some trouble. So don't do that. Don't give a credit card. That would be really, really great. Thank you very much. Okay, kind of getting to the end here. Because I'll show you a bit of a random thing at the end too, but you kind of get the gist. It's like, okay, deployment, pipelines are done, goes and puts it up on the cloud somewhere, makes it available. Netflix do this every day, etc. Probably just the last couple of kind of oddball bits. There's a topic called DevOps. I always find this interesting to talk about because I've been talking about it now for 5 years. And every time I talk about it, I have something slightly different to say because it's constantly evolving, You'll see this a lot with software, right? The general trend over time is that companies try and amalgamate roles together, is what I would say. So what you used to have, and I had a friend who worked at Optiva for a while, maybe like 3 or 4 years. He worked in their kind of ops team. What that meant was that he didn't write the software people use. He was responsible for taking the software people use and deploying it, essentially, or making sure it was deployed safely. And he would write code, but the code was to make sure things were deployed. He wasn't writing end user code necessarily. That was like a specific operations role to do with deployment. DevOps is a role, some would say it's a set of roles, some would say it's a part of a role that tries to focus on the fact that nowadays, because things are iterated on so rapidly, the people in ops need to understand the development side a lot more, or vice versa, right? It's not so much a case where someone just hands over an envelope now and says, here's my software, go and deploy it. I'll see you in a year when I have a new version. Things are a lot more ingrained. You also see this a lot with security these days as well, where because things are getting rolled out quite often, the capacity for teams and companies to have dedicated 100-person security teams it doesn't work as well in some people's theories than having, say, lots of the engineers have some cybersecurity background or putting a little bit of a security person in closer spaces, trying to bring that closer to the development side. So DevOps is a funny term. Some people are employed as DevOps engineers. Typically, that means they're employed as ops people who help manage cloud infrastructure, but also need to understand programming and are typically software developers themselves, will be pretty common. Sometimes you'll see DevOps referred to as, a part of someone's role, like you're a software developer who has also got some DevOps responsibilities, which means you have to deploy your own code. Sometimes you'll see it referred to as a set of roles or like teams. For instance, if you're a product manager or a team leader, a cloud architect, you might have some responsibility over how things are deployed out, right? The timing of it, how much to resource it. And again, this varies in different companies. In companies that are very complicated, like say AI companies, the cloud architects or the people who actually scale up the cloud systems, they're going to be really critical because there's just so much to that. Whereas at product-facing companies, people who are involved in DevOps decisions might be a lot more product managers or people in marketing or the product managers might have to talk to people in marketing. I can give you a million different examples of how this has played out, and it constantly changes. So I really hate with software when, particularly teamwork and project management, and someone's like, here's the textbook and here's like the way it is, because it just evolves quicker than you could possibly imagine. So what I guess I want to leave you with is DevOps is a concept that has acknowledged that many businesses benefit from the unsiloing of development and managing the release of things. Sometimes that's employing someone in the middle. Sometimes that's taking someone on either side and bringing their role towards the middle. Sometimes that's creating teams of people who share these responsibilities. Lots of different things. But that's only important to think about because you'll just kind of come across it in future. But again, if you're really struggling with all that abstract stuff I said, I would probably mostly just focus on saying that engineers are being asked to care a lot more about how their code is deployed and understand the cloud services. And I would say that for people whose sole responsibility is to manage cloud services, there's a greater emphasis on them understanding software development, or preferably being software engineers, so they can work with the engineers. And when something goes wrong, they're not just kind of like, totally in the dark with it. Yeah, it's a cute little diagram. This is from Byte Go again. Conventional software development, build, test, release, release manager, whatever. DevOps is like a bit more of, a close-knit cycle. So this one they're kind of describing as like DevOps is more a process, and then NoOps is like, this one's like an interesting idea. It's basically saying like, hey, there's more and more companies out there now, like Amazon and stuff, that handle so much of the deployment for you, right? Like for instance, Google, I maybe other companies, Microsoft probably does this well too. But Google has some stuff where you can upload code to them and your code will be hosted in Sydney. But if you suddenly get a whole bunch of traffic in Europe, they'll start spooling up servers in Europe and spooling servers down in Sydney. If you get a lot of traffic, they'll create more servers or remove servers, like give you more computing power. Lots of stuff like this that you can just kind of fiddle with now. And it kind of makes sense, right? Like 30 years ago, you used to have to understand all these things about, software engineers 30 years ago understood voltages on CPUs, right? If I asked a bunch of you, what's the voltage on your CPU, you probably wouldn't know, because you don't need to, because it's just totally abstracted in a near perfect way. So this NoOps thing's a really interesting point, which is like saying, hey, cloud services are getting so good that even the idea of DevOps for some companies will be slightly outdated because they don't need any ops. They just literally, it's like quite literally what services will do now. And what's a good example? See if I can find one for you. Yeah, this one might do. I was making a financial calculator the other day, right? See this URL up here. I gave Amazon a link to my Git repo. That's all I did. I said I made a website. I just gave it a link to my Git repo, and it takes it every time it sees new changes on master. It compiles it, it deploys it, it puts it up on the internet, and it puts it on this page. Nothing really needed to understand at all. So even this idea of NoOps is really interesting, particularly for smaller teams, particularly for newer teams. And this is what I was saying about, like, it's just evolving in ways that I couldn't specifically articulate that will last more than 6 months. So just keep an eye on it. Again, I hope at least I've given you a bit of an insight as to what to think about on the topic, rather than, rote learning to come away with. The last little tidbit for you today is maintenance and monitoring. So when Yu-Chao talked about the software development lifecycle at the beginning of the term, talked about requirements, design, development, testing, deployment, maintenance, or monitoring. We don't really talk about maintenance and monitoring in the course. However, it's worth flagging, just so you understand, that after deployment, after it's in the hand of customers or people, you need to monitor it. And there's two big reasons that you monitor it. The first one is to make sure it doesn't crash or break. What happens if you're noticing a bunch of users are getting errors? What happens if your dashboard tells you that their pages aren't loading? maybe there's a problem with the code, maybe there's a bug. The second part is enhancing user experience, which is about analyzing how people use your software to improve it for them in the future. So for instance, you can put tools on your software, right? You couldn't really do this in this course, but there are tools you can put on where it will actually kind of keep track in aggregate of where, if you have 1,000 customers a day, where are their mouses hovering mostly? Where are they clicking? So sometimes it's not that your code is broken. Sometimes the monitoring part is just important because it helps you figure out what are the next requirements that you're going to work towards to begin the development lifecycle again. And that can happen on a daily, weekly, monthly, yearly basis where you're like, well, now that we understand how our deployed code is going, what's next? What's next to improve the software for the people we're serving it to, right? But that other part is just maintenance, right? Which is typically like, sometimes, for instance, we would deploy some code and we would notice that the database was running at 100% CPU. What that means is that the database cannot process more. It's being asked to process more or at a speed faster than it can do. And it's just getting hammered. And that meant that the website's going slow for everyone. And if the website's going slow for everyone, what are we going to do about it? Well, we could obviously give it more computing power, or we could go and analyze the code and see what's wrong with it. Health is typically defined by developers. It might be things like looking for errors, and I kind of just mentioned the overloadedness of things there. Now, last thing before we wrap up, I just want to try and see if I can find you a quick example of a... Let me just see. Give me a sec. Yeah. Maybe I can find an old one from work. Give me a moment. So GitHub is by far the biggest. It's definitely become the prominent Git tool. Bitbucket from Atlassian has really fallen off the wagon. It used to be a lot more popular 5 years ago. I don't know what happened. I think they just stopped spending any time and money on it. And GitLab is cool. People like it because it's open source and stuff. But sorry, I'm just looking for something at the moment for us all. So my company, a couple of years ago, we used to use Bitbucket before we kind of got off and use something else. And I just wanted to show you this. So this is, oops, 2 seconds. It'll come up on the screen in a sec. I'm just trying to, I didn't really plan this, so I'm just trying to get it right. So this here is a bunch of commits that have been made to master years ago, right? And what used to happen was that when those commits were made to master, typically what would happen is it would go through a series of checks. It would scan for any secret keys that were accidentally added. It would lint it, test it, TypeScript it, all that. It would then build it. And then what it would do is it would zip it up and it would send it to a service up in the cloud. Which here, and it would kind of show a lot of details here, and it'll be like, yep, okay, we're going to like send it up to the cloud and it's going to go to the cloud. So this is an example of kind of how deployment might look in reality, is that this is kind of maybe the continuous integration part, and then there was a continuous deployment part after it. It was always automatic. Like, and then what happened? So what actually happened here was that this one was actually a continuous delivery one. It's been a couple of years. So it would automatically get uploaded to the cloud, ready for deployment, but someone would come in every day and click on that button if they wanted it to deploy automatically. Alternatively, right, there was another thing they could do where you could, I don't know how to do it anymore, but you could modify it to say that, hey, I want you to run this action every single time at midnight, and it would do that deployment anyway. But it was all kind of based on pipelines as well. And I think that's the main thing I kind of want to leave you all with the idea of, is that Pipelines are used for continuous deployment too, right? It's just continuous integration is the thing you do first. And there's lots of tools and boundaries around that, like should you deploy instantly and stuff like that, but it's all within the same ballpark. So anyway, hope that made sense. Anyone have any questions before we wrap up today? I'll give everyone like another 20 seconds. Sometimes the comments take a while to come in. Cool. Okay, thank you everyone. Have a great day and we'll chat soon. Thanks all for coming.